Well, good evening and welcome back to Lazy Astronomy. I know it's been a little while since I posted, and by a little while I mean most of the summer. But honestly, I was kind of going down the rabbit hole of figuring out some of my equipment. Tonight, I am actually using a new telescope and a new mount. I'm using an Explore Scientific 102 millimeter refractor telescope. And what a refractor telescope is, for those that may not know, is that's basically the telescope that most of us would normally think of as a telescope. It's all done with lenses, just a nice long straight tube. Um, some of the benefits of a refractor is really that it's a lot easier for things to be sharp and flat if you have the right kind of add-ons on it, and you tend to get a lot more contrast, a lot more darks and lights when taking pictures with a refractor scope. Um, it's also a little smaller than my old scope in terms of the full opening, which means I can take pictures of bigger things. So tonight we're going to be looking at the North American Nebula, which I've recently started acquiring on, so folks don't have to sit here and watch me focus and everything. Um, and as it stacks up here, we're doing exposures of about 60 seconds. So on our medium gain, this is some of the other stuff that I was trying to figure out over the last couple of months here, really trying to figure out the right settings for the camera. I think I've got some pretty good ones here tonight, so hopefully we'll see some good images here. After that, like I said, I also got a new mount. So my old telescope, when I was looking at on previous videos, was the kind of telescope that would track left, right, and up, down, which is really good if you want to look at the planets, or actually if you just want to look through the eyepiece. But if you want to take pictures, and especially if you want to take longer exposure pictures, the kind of mount that you really want is something that will turn with the night sky, and that's called an equatorial mount, which is what I put on here. It took me a little while to figure out how to work best with that as well. There's some things you got to do, like polar alignment, um, and for longer exposure photography, auto guiding, which I'm actually trying out here tonight as well. Um, so far, so good. It seems like we're about 4 images into our stack for a total of about 240 seconds worth of picture. And as you can see here, we're already starting to see some of that red nebula come out here. I'll adjust some of the settings here in a minute, so hopefully we can see a little bit more detail. But overall, lots of just learning this summer, which is kind of goes against my ethos of lazy on the astronomy part. But what I really look towards for something like what I'm doing here tonight is really making it that once I start taking the images, I can see some good stuff live. And then after the fact, go in and really process up a super pretty final image. And what I'm going to try to do on these videos is whenever I'm kind of doing a live session like this, is after the session's done and recorded and I've had a chance to process the images, I'm going to try to go back and put in as the original thumbnail and hopefully at the end of the images, end of the video as well, kind of what the final looks like once you really take this into some of the more sophisticated tools to really, really process the heck out of it. But as I mentioned tonight, we're looking at the North American Nebula. Now, let me play with some of the sliders here, and we'll see if we can bring out a little bit more contrast and detail. And hopefully it'll become pretty apparent why this is called the North American Nebula. So let's bring this down a little bit, bring this one up a little bit. And this image should get better over time as we've got some more going on here. But there we go. For right now, I think that's pretty good. So if you imagine this flipped on its side, and let me take off the crosshairs here. So since I know what I'm looking at now, I no longer need to kind of zero in on it. Show crosshairs. There we go. So if you imagine this flipped on its side here 90 degrees, this is one of those ones that's named because it kind of looks like something. So if you look at this darker area here, imagine that's the Gulf of Mexico, and this would be Florida here. and this would be Mexico coming this way, and the rest of this would be the larger part of North America. And that's really where the name of this one comes from. For folks that may be showing some of this video to their kids, let me tell you a little bit about this nebula. So, first of all, this kind of nebula is what's known as an emission nebula. And what that means is that it actually glows in space. You see these bright stars all around here and the various stars that are in here. These stars send out solar wind all the time, just like our sun does. And what happens is that solar wind comes across a bunch of gas out in space. In this case, it's hydrogen gas. And when the solar wind hits that hydrogen gas, it makes it start to glow, kind of like a fluorescent light, that you might have in your house. And any element, anything that you, any substance that you put under a certain amount of energy is going to glow, and they glow at different colors. So when I said that this was hydrogen gas, the reason why we know that is because of the particular color that it shines in. In this case, pretty much this whole nebula, as you can see, is very red. And that red coloring really only comes from hydrogen. And so a lot of what we call the emission nebulas are actually mainly hydrogen. And one of the reasons why that's so common is because hydrogen itself is the most common element in the entire universe. Most of the stars that we have out there are mainly hydrogen. So when you look at the dust that's in between stars and throughout the galaxy and even between galaxies, most of the time, the gas that you run across, or the elements that you run across in that, is hydrogen. Now, you do see a lot of other things. Specifically, you see a lot of oxygen out there. And you see a lot of, I believe, I'm trying to remember what S is in the narrowband line, probably silicon, I think. And maybe sodium. I may be having that wrong. But those three elements tend to show up a lot in nebulas, at least from the point of view of what we can see here on Earth. Now, when you look at it with something like the Hubble or some other kind of super special tools, you can actually look a lot deeper into those nebulas and find a lot more other elements as well. But hydrogen is mainly what you see most. Now, we've got a few more images in here. I'm going to set this back to the auto range, see if it thinks that we can get any bigger pictures as I kind of jump around on some of these. That gives me a lot of edge, but not a lot of pretty to it. That's starting to look pretty, but not as deep yet. Just kind of bounce around with a few of these for a minute here. Well, that's a great view of the stars, isn't it? The high is just too much. So why don't we take it back to this one for a minute, and I'll just kind of dial this in a little bit manually, see if we can get it starting to look a little bit better now. Problem is, when you get real close like this, you can see a lot, but it tends to look pretty gnarly. So I'm going to try to bring this down a little bit here so that we can still see some good detail in here without it just looking like a crummy image. There we go. I think that may be pretty good. And I'll continue to play around with this a little bit here and there. This is really the big advantage of doing that processing after the fact, because if we zoom in on some of this kind of stuff here, you'll see just all of these kind of different colors that come in here. That's basically just the noise of the camera itself. And that's one of the reasons why we take a lot of images. So like I said, we're up to 11 right now. For Spinal Tap fans, mine goes to 11. but we take a lot of images because over time those pixels of color get averaged out, and essentially then you can kind of get rid of most of this and just make it all black, which is really kind of your end goal, so you can really get a nice clean distinction between like the edges of the nebula here and the stellar background. So I was going to look up real quick a little bit more info about the North American Nebula here. So let me find for just 1 minute. Which, by the way, I highly recommend little planetarium apps for your phone. That makes a lot of this so much easier because not only can it tell you where to look in the sky, in my case, it can actually help point the telescope there. It also gives you some, some kind of interesting information about the object itself. So, as I mentioned before, this is an emission nebula. And for anyone interested in kind of finding this in the sky, this is actually near the star Deneb, which for the time of year that we're at right now, which is going to be kind of mid-September, Deneb is almost straight up. So, if you look straight up, North America is kind of maybe looking back down at you. It's pretty big. I mean, if you were to take the full moon and overlay it on this image, the full moon would be about this big. The North American Nebula is actually about 4 times the size of the full moon, which just kind of goes to show how limited our eyes are when we're looking at things out in the universe, in comparison to what the amount of color and detail really is out there. Because I don't know about you, but for me, if I was looking up right now, maybe I might consider the sky black on a generous night. Right now, I'd probably call it more gray. Um, so thinking that you have this kind of color and variation just sitting out there is kind of crazy. Now, the other funny thing is, how far away is this? There's a lot of different things that we can use to measure distance in astronomy, mainly stars that are very similar to each other or have a standard brightness, which a lot of times is called a standard candle. But really, we don't exactly know exactly how far away this nebula is. Nor do we really know, kind of which of these stars in the image is really causing the brightness, causing it to actually emit in the color. Some people believe that Deneb itself is the star that's really lighting everything up. Which, if that was the case, it would make the nebula itself about 1,800 light years away and about 100 light years across. And so to think of that, let's assume that that's the case. If this is kind of getting towards one tip of the nebula, and we were to say this is another one, the nebula is actually even bigger than my camera can image. But let's say we went from here to here, and that was 100 light years. What that's really saying is that the light from this edge would take 100 years to get to that edge, and vice versa. And in the case of this overall nebula from Earth, 1,800 years ago, right? That's when the light from this nebula left and started making its way here. So that would put us, at about 200 AD? So, 200 AD, end of the Roman Empire kind of time frame, or towards the end of the Roman Empire time frame. That's when this light left the nebula, and it's just now getting here. And that's another really neat thing that I love about astronomy is that anything that you're looking at here, short of the moon or the planets, is really kind of a certain amount of time travel, where you're really looking backwards, potentially in some cases hundreds of thousands of years, for the objects that I could see. looking at, things like some galaxies and stuff. You may even be looking back millions of years. And then obviously when you get to things like the Hubble telescope and radio telescopes and things like that, looking at the microwave background radiation, they're looking back billions of years because it took the light that long to get here. So that's kind of my spiel. I'm going to try not to get too bogged down in full technical details of what's going on here. But I wanted to kind of show this and show kind of how things are working as I'm kind of testing through my new setup here. I'm going to readjust the image for color, kind of color and contrast one more time here. See how we're starting to look. We're definitely starting to reduce some more of that noise for what we've got in here. So the nice thing about this is I can just basically let it run. And I'm probably not going to keep myself online here with everybody for too much longer. What I'm going to try to do is basically let this run for about an hour and pause the stream, and then come back once it's been running for a little while here and seeing kind of what the output of this really looks like, and then kind of show it to you guys from there. Let me do kind of one last jump around here on everything that we're looking at. Just want to see if any of these pops it better than when I was playing around with it by default. Oh, this is actually starting to look very nice. It's faint, but boy, a lot of that noise has kind of jumped out. Let's see. Medium's kind of what we were looking at. High's going to look awful. And go over to the mean. Not quite great. Okay, yeah. So jump this back over to low. So that's what we're playing with right now. We're just kind of letting this fill in more and more over time here. Let me play around with the brightness a little bit, maybe brighten this up, and maybe even saturate it a little bit more so the red jumps out a little bit. It's probably a little too high. Yeah, maybe the saturation was fine where it was. And we'll try to brighten it up and darken up the background a little bit. Yeah, so starting to get some pretty good views of this here. So, and one other thing that I wanted to put in for any folks that are interested in learning more about how you go about doing this kind of stuff. The whole kind of class of um, astronomy, where the idea is try to look at stuff live as much as you can, but being able to really see like these colors and nebulas and stuff that really requires having cameras on them. Is something known as EAA, or Electronically Assisted Astronomy. If you do a Google search on that, what you'll find is a bunch of different folks out there with a whole lot of different setups and equipment trying to do essentially what I'm doing here right now. Taking a camera that's pretty sensitive and a decent telescope, and seeing what they can see live, more so than traditional astrophotography, where you take a bunch of images, maybe you kind of see one image at a time as you're messing with it, and then you take it all back inside the next day and slowly try to piece it all together. And take hours and hours to finally get something that kind of looks pretty decent. So that electronically assisted astronomy is something where, in this case especially, I'm kind of looking at this as hopefully best of both worlds, where I could see some of this stuff, maybe even hopefully share this stuff with you guys, for anyone who might be interested in watching this kind of thing, and then take it to the next level, take it inside, and really try to process the heck out of it. So yeah, so that's it. North American Nebula. Like I said, I'm going to go ahead and pause the video now while I kind of let this run for a little while. We're at about 21 frames or individual images at what I say, 60 seconds a piece, so we're about 21 minutes in. So I'm going to give it another 20 minutes, or no, I'm sorry, about another 40 minutes here, and really see at the end of the day or at the end of the session here, kind of how much more detail, this, how much more we can really seem to get out of this once it's had time to really stack up a lot more info. So for anyone who's been watching, thank you. I don't actually know once I hit this pause button if it's actually just going to pause